We see a lot of challenges in the next couple of years coming from the customers and coming also from the governments. So the OEMs have to develop solutions and offer solutions how to minimize the weight of future vehicles.
So in the future, instead of seeing an all-steel structure, we'll see combinations of high-strength steel, aluminum, composites, magnesium, and plastics in an optimal combination to reduce cost and meet the performance that's required. The key to the utilization of new materials is to find the best application and best mix of different types of materials.
We are experts in the development and engineering of lightweight structures for automotive structures in mass production. Our core topic is how to work with composite materials. We have to think beyond the current technologies, and we have to think forward for our customers. With only 950 kilograms and 320 horsepower, we developed one of the lightest sports cars worldwide, and we could also homologate it and sell it to the customer. So with that experience from creating one of the lightest sports cars worldwide, we got a lot of attraction from industry customers.
For companies like Forward Engineering, Fibersim's a great fit.
With Siemens Fibersim, we are able to simulate the draping behavior of a carbon fiber textile. What does the textile do in a 3D shaping process? And of course, we have to make sure that the draping behavior is right and the part performance is there, because the part performance gets defined by the fibers and the fiber angles. And with that draping simulation, we are able to get a better understanding where are the fibers in the final part.
It runs within the familiar CAD environment that engineers use. And secondly, it converts the CAD environment into a composite engineering tool. So a company like Forward Engineering can take the experience they have working with composites and utilize that experience efficiently.
Our challenge at Forward Engineering is to use software tools which are covering the demand of mass production, and the software tools have to cover these type of processes.
Software like Fibersim provides engineers with the information they need, especially early on in design, so that they have the information they need to make the right choices. If you look at the menus that Fibersim presents within CAD, it actually steps the engineer through one step at a time. A new engineer to composites can take these challenges on one at a time in a menu system that's really tailored to the way the composite engineer thinks.
The reason why we decided to choose Siemens Fibersim was, as we have seen during the evaluation, that software is growing and developing with the topic. And the second thing what we liked is that we had an open interface to simulation programs. So this type of interoperability was very important for us, as we are working with many different simulation software. As you understand that the mechanical performance is defined by the fiber, so the knowledge about where is the fiber in the final geometry is very important to get a certain result and to make sure that the part performance is right.